the paper, boy. Extra, extra. Fuck with me, you know that I got it. Come with me, let's take a trip to the islands. We up on the jet, we'll do more than just fly on it. Stand on that hill, you gon' die on it. Boom, boom. Baby, I'm not one of them, you should try on it. Miss me with all that, I'm on it and next. Fuck this up, I send you back to your ex. But good luck with that, this is big as it gets. Ayy, let's see how you do under pressure. Let's see how you do under pressure. Give them a name to remember. Ayy, let's see how you do under pressure. Let's see how you do under pressure. A moment can live on forever. Yeah. Oh shit, they don't let me shoot a whole clip. Firepower in this coalition. We just turned the field into a demolition. It was desolate, but I had premonition. I was training for war, every exhibition, every extra mission, every enemy listening. Get off my dick, I got bad intentions. Make it right every wrong, and I'm back with a vengeance. I show you the ropes. Peace in my town, I can show you the coast. Up in the shots if they wanted to smoke. If you know, then you know. Suited up, bitch, my whole team do the same. Don't you forget who created the game. Ready for war, I was born with grenades. The trenches where soldiers are made. Let's see how you do under pressure. Let's see how you do under pressure. Give them a name to remember. Ayy, let's see how you do under pressure. Let's see how you do under pressure. A moment can live on forever. Let's see how you do under pressure. Let's see how you do under pressure. Give them a name to remember. Ayy, let's see how you do under pressure. Let's see how you do under pressure. A moment can live on forever.
Okay, is this thing on? Let's see. Looks like it. A little bit, missing a little bit of light. Let me turn on my second light. Forgot, I only use one light when I'm not streaming. There you go. A little bit more balanced. Okay. Alrighty, so today, I'll turn this down a little bit, hold on. Music's a little distracting to me. Okay. Oh, that's a little bit too quiet though. Balancing out my levels a bit. Yeah, that's probably fine. Okay. So, today, we begin our journey with Rust. Our grand journey with Rust, because it is perhaps the leading industry standard now, due to Joe Biden's administration putting out a paper talking about the future of our cybersecurity as a nation in the United States. So, did a little bit of reading on it. Not super familiar with Rust, but I did go ahead and install it on my computer. My goal by the end of the stream would be hopefully to get this thing blinking. Maybe not blinking, but at least programmed using the Rust toolchain, because that would at least get us to the starting point that we kind of were a few streams ago. Shouldn't have to change too much because of some of the tools that I've seen, but I think we can just go ahead and start. Go right to it. So the first thing that I came across is when I looked up Rust. Oh, let me zoom this in a little bit. Rust 32-bit is, or STM32, is that there's some stuff that already exists. There's these things called crates that I'm learning about. This seems to be like the core key, I think, to get myself with a Rust platform on my chip. Hold on. We're gonna choose a little bit more chill music with less lyrics. Okay. Anyways. So this one, this tool looks like it allows me to grab basically the equivalent of my header file that has all of my macros of registers. This tool may already have it. And if it doesn't, that means we could maybe contribute to this repo. I haven't really looked into it too much. Just making sure that this is right. Okay. Wait, hold on. Okay, yeah. But apparently it has something. So let's see where we can start. We can go to the learn and go through this book here. That's interesting. So you can make a few different applications for Rust. It's kind of neat that you can just have it used across multiple stuff depending on what tools and how you write it, I'm guessing. But in short, we want to make sure we have all these tools here. That's step one. We're on Windows. I already have... Hold on, let's see here. I already have... Does this shortcut work? I guess not. Let's get PowerShell up. Let's get just command prompt. That's fine. Okay, yeah. I should already have ARM. Oh, hold on. Let's see, PowerShell, I think. PowerShell. Yeah, should already have ARM. Yay, BGBD. Okay, I do. So we're good there. Welcome back, Architect. Welcome back. Nice sine wave. Have you heard anything about this? Maybe not. You're in the game dev space, so maybe you may not have heard about this, but Rust might be more relevant. Maybe more relevant. Okay. Alright, well, we have a much newer version. That's fine, hopefully. This is just an old document, so I'd imagine it's going to be a little bit out of date. Open OBCD. Something indeed. Okay. It's going to be something, that's for sure. How much of that something? We don't know yet. Okay, looks like I have my debugger. QEMU. We may skip this step for today. So that's for emulating the chip. I don't think I'm going to get to that part. Although it would be really cool. I should at least download it on my PC. I'd say. Interesting that they are having you build it through this Pac-Man. That's a new command to me. Is Pac-Man something here? Partial Pac-Man. No, no Pac-Man. Yeah, Pac-Man's not a thing. I thought so. Let's see. QEMU is installed using MSys2. After I saw that 12-bit DAC, I actually implemented 12-bit. Oh, really? Weren't you working on oh, hold on. I just realized. It's hard to see chat on a white background. But go on. You implemented 12-bit? Because weren't you doing a 8-bit before? Or 16-bit? You didn't have a 12-bit? Chat, let's see. Let's change this background. Your title is gold. Thank you. I love Strux. That's a great name too. 8 and okay, 8-bit and 16-bit. Yeah. That makes a lot of sense. 12 is used, you know? I mean, I don't know if your game would run on my hardware, but you know, 12-bit audio is a thing. Okay, I'm trying to figure out a good background for the chat because I noticed the playback is white on white, which doesn't look good on stream too much. Text colors white. Background. Yeah, background should be back. Well, I saw for a second there, but it went away. How has embedded Rust been going? I'm thinking about getting into embedded, but all I have is apply and want to start a little bit easier. I'm starting from the ground up right now, so I can't say from expertise, but from what I looked, there seems to be already a good community for it. There's already some projects to help it. I guess I'll just have to put it here so this can be seen. But I think it's been around for enough, long enough that it's not that bad. I think it's getting over the hurdle of learning the syntax of the language. And then outside of that, it's not going to be much different. Granted, I'm coming from a perspective where I may not be using a lot of libraries that exist. Like with my C code, I planned on writing a lot of my stuff from scratch, so doing it in Rust doesn't change that. I still have to write it. I just need to get the tooling to compile my code and get it onto the actual platform. It looks like my debugging tool is going to be the same. My flashing method's going to be the same. It's just a matter of the syntax, really. And then finding bugs might be easier eventually because there's a lot of things in the compiling of Rust that will protect your code. And I saw a really cool feature in it that is super relevant to embedded, where if you turn on some hardware, you can make, like, let's say you're turning on GPIO or like an LED, but your processor requires you to turn on some other part of the processor before you can do that. If I'm not mistaken, you can tie that function together so that way you wouldn't be physically able to compile or run your code unless you called that previous function that lets you turn on that other piece of hardware. So like dependencies, which was a huge problem that I had when I was doing C-based stuff, because all I have is the documentation on this thing, You know, it tells me, okay, you could turn on GPIO, but you had to be very lucky to find just that one paragraph in the documentation that says, oh yeah, by the way, in order to use GPIO, you need to turn on the clocks as well. And it's just like, oh, exactly. Hardware dependencies, right. And it's super hard to just know that off the top of your head. You get it with experience, but you know, I'm still like a year, 2 years into this field, so it's still a learning process. So I'm kind of looking forward to that. And it looks like a lot of those files that talk about those dependencies exist already, which is why I'm also pretty excited to try this out, because like even from last stream, I was running into that problem. So yeah, that's pretty cool to me. But getting into the QEMU, I probably won't do that this stream. I'll probably do that off stream or something. What I really need is just to be able to maybe compile example code, or yeah, I guess that would be good. So let's see. And oh, one of the better parts about Rust is this documentation. It's so modern. It's so fresh. Has anybody ever seen the C documentation? Let's see. Okay, maybe this one's more modern. Okay, this one's not as bad. But still, it's pretty small. It's not super bright. It looks a little bit better than the one I was thinking of. And if I go to C++'s documentation, I don't imagine it to be any different. Okay, maybe it depends on where you're getting it from. This one looks to be a little bit of a better website for displaying it, but I still prefer, where's Rust? I still prefer this. This looks like a modern web page, you know? That motherfucker is really good at making docs look good. Yeah. This is what I want my documentation to look like if I was generating it. This is the clean stuff for sure. If I'm looking at this, I mean it works, but it looks more dated in my opinion. MD book. Is that what they made it out of, by the way? Is that what they use for this? Oh, you can change your theme even. Look at that. Oh, my eyes. That's cool. I wonder if that's part of it already. Yeah? Okay. That makes a lot of sense then. Yeah, I mean, outside of today, I haven't used Rust at all. Flashbang, yeah, I'm sorry about that. It's funny, though. Themes built in. Okay. Oh, that's right. Yeah, I saw that. That's, I think on the front page, you could run an example Rust thing. Yeah. Okay. So let me see if I can just go ahead and try this out. So we're gonna skip QEMU. Hardware. I do know my hardware a bit. Like I know what core I am. I might need to recheck the flash memory size. I mean, I wouldn't imagine a situation where we don't come across stuff that already exists for this chip specifically, because it's been out for at least 2 years, I think, at this point. And I think the Rust community is pretty eager to get more platforms supporting it, just because they really want to make their time worth it. You know, they learn this language. I feel like it's a good idea to get other people excited about it, and by making their other boards support it, that's a good thing. All right. Cargo generate. So I just learned about Cargo, which is the project manager or package manager, which if I type Cargo here, looks like we have it properly pathed. So I guess we can just go straight to this. Although I wonder if there's a different repo that has my chip specifically. Oops, new tab. Let's see here. We got Rust. Look, they got Raspberry Pi. You're pretty new to Rust as well. You're taking the gamble of the space entry will adopt in the future. Yeah, see, exactly. Do you follow low-level programming? Because that's where I found out about this, from that YouTuber, Twitch streamer. I thought it was a pretty interesting thing, and I was like, you know what? It could be relevant, could be good skill. The moment when ARM processors don't have a dedicated integer instruction for division. Really? Some ARM processors. Okay, yeah. That's interesting. So they expect you to implement one, or just be okay with the floating point based one. That's a little bit unfortunate. Okay, so this looks like to be the Rust repo. So we go into here, maybe we find some stuff. This is neat. I've been seeing a lot of these cool not packages, but these cool tools that people have made, such as this one, SVD to Rust. If you're familiar with register stuff, it looks like you can give this tool some kind of XML or JSON-like file of the registers, and it'll generate out the macros necessary to use that. Which normally you just had to rely on, let's see, is this documentation? Okay, maybe not. Before you had to just rely on an existing header file if it was C or C++. So I wonder if we can get this up and running today, this part of it. Because I think that would be the missing element that would save me a bunch of time. Cortex-M, okay. Our chip is M, but it's a M33 specifically, which it looks like this one might be having multiple M's, like supports multiple versions of M's. 12-bit is not at all what I was doing with the audio encoder of my, oh. Yeah, I mean, you had the 16, you had the 8. So you had to, what, completely do something different for the 12? Is that what I'm hearing? Cortex-M. 10-bit? Oh, okay, changing it up a bit. You're doing 10-bit. So you needed a 12-bit to fit the 10-bit data? Is that what I'm hearing? Or did you make a 10-bit version of your library? Let's see, peripheral. Okay, so these are all Rust source code things or files. Like the actual MCC or M33. You could get lost on GitHub when you filter by Rust project. There's so many good ones. I like the cross-platform command tools like rip grep for grep and bat for cat. Oh, they changed it because I can't use the Linux ones on Windows. Oh yeah, I see. The people made these tools so you can just go ahead and do that. Oh, but they're made out of Rust, which is oh, I see now. I see. I didn't even think about that. Rust is cross-platform. I read about the way you don't even need Rust installed to run it if you have an executable of it, which is pretty cool. Pretty cool. That's actually a really good point, though. I mean, I installed, what is it, MinGW, so I could do things like grep, I think. Oh, maybe not. I can't recall. I feel like some Linux stuff gets brought in from MinGW, but maybe I'm wrong on that. Either way, when I'm in bash mode, sometimes I can use that, but maybe not. I don't use grep that often. I haven't used cat that often either, so yeah, maybe I don't have that, but Rust would add that, and I love the names rip grep. That's pretty funny. Rip grep. No longer. It's no longer needed. The rest alternatives have a lot more features. Even better. Upgrade of. No wonder it's a rip grep. Yeah, rip those greps. Okay. This had a lot lower stuff than I was looking. than I was hoping for. I mean, it has my core, my ARM core is a part of it. It looks like it's just a generalized Cortex M. So how about we go back to the documentation and see what it suggests. So this is the quick start. Maybe I just need to compile for a different target and I'll be fine. Yeah, maybe. Let's try it. So I go cargo. Oh, actually, do I want it to be in this folder? I don't really want it to be here. Let me put it in, let's see. I think it's my D drive. Give me one moment. No, it's not. Hold on, let me open my File Explorer. Can't recall. I put my development in a isolated spot. Oh, I see. Okay, wrong drive. Okay. And then go to here. And then let's see. So what are we doing? We're just making an example project. Okay. So we can just make a new one. That's fine. Cargo. Yeah, let's cargo generate it. Thank you for the follow. I love structs. Structs are nice too, but I don't know if there's structs in Rust, unfortunately. This isn't Rust. I thought you were playing Rust. Oh, no, no, no. It's a different kind of Rust, my dude. I'm sorry to disappoint, Phil. Alright, it doesn't know the command generate. Well, that's not fun. Oh. Refer to previous section on QEMU for how to do this without cargo generate. Maybe I did need QEMU. Let's go back really quick. Enums too? No enums? Oh. Oh, no, there is enums and there is structs. Okay. Got it, got it. I haven't gotten that far into the syntax yet. I've just learned about the functions having the ability to return stuff without return. The keyword return. It's blowing my mind. I'm curious about the readability a little bit of Rust on like a big project. Because I haven't looked through any source code like that. Okay, what do we got here? Creating a non-standard Rust program. So, oh, I see. I need to install that tool. Cargo install. Cargo. Let's see if this works. I don't know if it will. Okay, it will. It did. That was pretty easy. Yeah, Rust has some neat things that I'm just simply not used to in the C world. It changed, it just has some new ideas, like with immutable stuff of having that ability. The shadowing of writing things, that's new to me. Cargo installing itself. One thing the compiler will never let you forget is the types have to be defined for parameters output. Yeah, I did read a bit of that, and I thought that was pretty interesting because, I mean, it'll just prevent me from making these silly mistakes because I have, again, done this on stream already. I don't really see a problem with it. Maybe it can get annoying, but I mean, it's only there to help make sure you're getting exact data. If anything, this just yells at you more than C would, but again, has a good purpose, I feel like. Okay, this is stuck on one binary. Oh, because building. That makes sense. It's building the whole thing. So if we install that, we can generate it. Okay. I guess I could have used this, but I kind of like... If I used the Git report... Oh, I see. Maybe this would have been better. It's just an alternative way to get a repo. You can use it directly through Cargo. Maybe it does some additional steps too. Let's see. Is there any Anything they note here? The project has some bare metal or bare bone application. Okay, it doesn't say it's doing anything different. Although this step is different as opposed to you doing a git, creating project name app. Yeah, I wonder how that'll be. So it'll be a simple program. Looks like, I'm guessing these are preprocessor called flags or something. Pretty sure I was looking at this earlier. Yeah, indicates the program will not link to standard crate, and crates what they call libraries in Rust. Is that right? I think I heard that or read that. No main means you don't have a main interface. So then how does it know? Oh, this entry literally answered my question just a few lines down. I was gonna say, how does it know where to go as soon as you start? So this is a crate, and you're calling this keyword from the crate. I think that's how it works. Panic handler is a crate. Entry is an attribute from this crate. Okay. Yeah. There's just some new lingo. Some new lingo that goes on with this. Oh, okay. We installed cargo generate. So now we will copy this and pull the repo. Okay, how do I? I'm not a PowerShell user. Oh, I see. I think it's yeah, here we go. All right. Project name. Okay. We will call this test STM32. All right. This is. Oh, maybe these examples? Is that what's going on? Am I choosing an example? Hold on. Let me go to this repo again. Oh wait, yeah. Let's go to this repo. Examples. No. No, this is just the name of it. I don't think it can take spaces. Okay. Test. STM32. Got it. It even changed how to name it. There's a naming standard. Interesting. Okay. Well, we created it. So if we go into test STM32, we can open this up in VS Code. And oh geez, that's too big. All right. I installed the Rust extension on GitHub, so hopefully it's easier to look at this stuff. There seems to be a couple different stuff added into this repo. It's somehow got my name and my GitHub name. How to use GDB. That's pretty nice. We'll have to look through that a little bit. Yo, what's up, Johnny? Welcome, welcome. We just got our Rust repo pulled. I'm gonna start compiling our first Rust thing. Okay. We can get rid of that. Let's see. So this was talking about the program. We need to see what this is about. Next step is to cross-compile the program for Cortex M3 architecture. That's as simple as running cargo build -target $triple. If you know what your compilation target should be, luckily this toml, this template, has the answer. So do I just look through that? I guess I would probably. Cargo toml. .cargo.config toml. .cargo. I guess I don't. Oh, up here. All right, here we are. So we have the M33, and we can choose if we want the floating point unit or not. Okay. I will probably use the one with the floating point. That seems fine. Pick one of these default target compilation. Should I like uncomment this to make cargo run? Okay. Gotta see. I'm gonna have to learn a little bit how this tonal system works. Uncomment one of these to start a GDB session. So if you choose this one, you're doing it through the ARM compiler, or not compiler, but the ARM GDB, which I do have, so I'd probably use that. If you need to link the pre-compiled C libraries provided by C chain, use GCC as the linker. Okay, I have this linker, so I'd probably use that too. I wonder if I needed to uncomment this or not. Either way, it looks like that's how they're selecting these options, and it makes it easier. Because if I was looking at this, you just run the toml instead of getting to... Yeah, this is like your make. Okay, yeah, never mind. Uncomment one. There, done. Uncomment this to make cargo run, execute program like EMU. I'm not doing that right now, so we're gonna ignore that. And then this one, if you need to link. I don't know if I need to just yet, so we'll leave it commented, and yeah, we'll start there. Okay. So tail just shows you the last bits of the file. So we don't actually use that. To cross compile for the Cortex M3, we'll use thumb v7. Do I have to type that out? Is that the key here? Come into here. I just have to enter this in. Is that what's going on? What was the command? Cargo build dash. Oh wait, hold on. I just need to add it first. All right. Rust up target add v8m dot main eab hf. Is there auto? No autocomplete on that. Okay. Installed this standard standard library for this ARM chip. Now we're gonna build it. Why would you need? Ooh, I'm curious why you need to call it twice. Hold on. Since this compilation target has been set as your default, the two commands are the same. Okay, I see. So if I just do cargo build, that should work. All right, there we go. Cool. Cargo build works. Now we have a non-native ELF binary in this directory. We can inspect it using cargo bin utils. Okay, so if I type in cargo bin utils, that should be a tool. Okay, I don't have that tool. Must be a different tool. They're kind of just skipping past it, I think. With cargo read object, we can print the ELF. So we don't have that. So do we just install it? Is that how that goes? If I do cargo dash bin utils. No. How did we install something earlier? It was install. Okay. Sure. Let's do it. Cargo install cargo bin utils. There we go. We're getting it. Easy enough. This is way more like a Python experience that I've had. Just getting these packages. Granted, these seem to be like scripts. Just help your development. Okay, so utils adds a bunch of crates. said the read should be in here. Object dump, read object. Okay. So now we can. Where did that go? Let's build, inspecting, read objects. So you pass in the binary. I don't know what the double dash is about, but dash file headers. Okay. So cargo, read object. Dang, no autocomplete on that. Read. Read obj. Dash bin, and then we want. Wait, where did they compile it to? Oh, I see. In this directory. I wonder if you can do it without passing in the exact path. I'm just gonna try it without passing in the path and see if it can find it on its own. So what are we doing? This is like test STM. Actually, let's look. It said it was in target. The name of this debug build. Wait, was it build? /app. Don't quite see it there. Target. V70 ABI. That'd be here. Yeah, it should be debug app. I don't really see it. Maybe it's in a different spot nowadays. Build test STM. I see out. Is it a .x? What is there? Oh, ELF. Yeah. Let me just see how it works. Cargo. Read obj. Dash binary. Then we will do test dash STM32. Could not find tool read obj. Interesting. Okay, maybe I need to pass the full name to them. Rust read obj. Unless you need to restart the bash because it's a new. No, it should be in the directory still. Cargo, Rust. Yeah, no autocomplete on that. Dash read obj dash bin test dash STM32. No such command. View all installed commands with the cargo list. Okay, sure. Cargo list. Yeah, okay, it doesn't think it. Oh, read obj. It's right there. Was the command? Oh, maybe the arrow was something else. Where was it? Could not find tool. Let's try and restart the bash. Maybe it needs to load it back. Everybody, yeah. How about we do it in PowerShell? Okay. So we wanted cargo. Cargo. Let's do this. Copy the command. Except change binary to test STM32. Could not find tool read obj. Unoptimized plus debug info target in 5 seconds. What if this was app? No bin target named that. Okay, so it does see a target called STM32. Test STM32, but it doesn't know. It needs a component. Okay, sure. Component. Add LLVM-tools preview. Let's look up what that is before we enter this. Rust lmvm dash tools dash preview. A new Rust up component for binary inspection. Okay. Whatever. Seems fine. Let's just go for it. Okay. So now if you run this command. Alright. There we go. So what are we looking at here? This is our compiled code. This is our file type. It's interesting how cargo is usually right 99% of the time. Wow, that's wonderful. I mean, I'm fine with that. I just get a little scared because I don't know what it's doing, you know? It's a new thing. Okay. This thinks it's a system visor, I guess. Unix system visor. Is that what that's going on? I'm definitely not on a Unix system, I can tell you that. Maybe it's because I'm compiled for ARM. Okay. Like the compiler is made for Unix, so maybe that's why it chose that. Version 1. Entry address. Okay. Alright, it somehow knows my processor already. That's cool. Let's see what we got here. Cargo size can print the size of the linker sections of the binary. Sure, let's try that. Cargo size. Binaries, test STM32. Release. I would like to know what this extra dash is about. Okay, it needs to install something. Or no, it's compiling something. Never mind. Alright. So we got it. I heard it gets less helpful when you get into async and stuff, but for imports and syntax issues, it's really nice. Okay. Luckily, asynchronous stuff isn't really necessary for non-multi-threaded stuff. That at least I can think of. Asynchronous, well, maybe if you're doing UART, I guess that's technically asynchronous, but when I think of async, I'm thinking of two different threads. Is there a different idea that goes with that async that you can think of? Or maybe I'm just missing the point completely. Okay, vector table at the first. Yeah, that sounds right. That's your ISR related interactions. Your .text. They did say our code starts at 401, so that makes sense. Read-only data, BSS. This program is pretty simple, so it shouldn't have anything in there as it's showing. These are all debug flags that they created, so I know nothing about that. Same here. Comment section. I would like to know what's in there. I don't know if I can with this tool or not. Let's see, does it say anything about reading in a particular thing? This is dash all. Oh, look at that. Do any of these talk about it? No. It's just saying how the ELF organizes this. Oh, strings is in read-only data? I didn't know that. TBH, I know very little about async. It seems very useful to know, but it's a little later in the tutorials and books I'm using. Okay. Well, you and I both. We'll both get there. I just know that async sounds a little bit scary when it comes to safe low-level code. I feel like I've heard of it in JavaScript or something. Like that keyword, I've definitely heard in another language. Okay. Oh, you can disassemble the binary, so that way you can see the assembly line. So let's do that. It's a handy tool. It validates that it made compilation or made instructions that make sense, especially if you're trying to see if they're being optimal. Okay. Yield and generate is async is crazy. Okay. Okay, Zest. Yeah, I mean, you would know more about that than I would. It'd be a little worried if somebody told me the plane I just boarded is testing some new async. Yeah, I agree. I totally agree. That would be. I mean, shoot, you've already seen enough of the videos about recent Boeing planes having some issues. Granted, that could be a number of problems, but you know, just throw a newly designed software system on top of that. It's not a very confident flight for me. Okay, I would like to kind of type this out so I can see what's going on, what they're calling, rather than just copying it. Copy and pasting. So object dump, the binary should be, oops. Binary should be test STM32. Okay. Release, disassemble, this is calling the disassemble flag. Okay, because did we call obj? No, we called size and read obj. No show raw instructions maybe, and prints intermediates and hex. Okay, what do we got here? Yeah, I'm on Windows. This is Windows. I'm just using PowerShell and VS Code. Okay, this is a lot of code just to say hello world. I think our code is what? It's just our source code is here. I guess we have these entries and we're linking these crates, so maybe that's where the extras are coming from. We have a no operation and we just have a loop that loops. Reset flag. So this is where code enters as soon as it starts, because it said code starts at 400. We have this pre-initialization. We're moving some registers around. I'm not gonna know much about that. I'm looking more for tags, I'd say. Main. Okay, so we have main here, main function. Here's the main tag here. We're pushing the load register onto this, stack pointer onto this, or maybe it's the other way around. I have to refresh on my ARM. I kind of forgot my ARM a bit. ARM assembly. Block load. Breadboard setup you have as part of a kit. So this actually is separate from this. I bought this STM32. It's a Nucleo development board. A Nucleo development board. Or I said it again. An STM development board called the Nucleo U575. Yeah, it's the name of the chip. It's not very creative, but anyways, this is a development board, just like you'd get Raspberry Pi, just like you'd get an Arduino Uno. That's technically a development board in my eyes because you have the chip that's on a larger platform. Raspberry Pi is, I guess, a little bit of a different situation since they only sell you the whole module. I guess with the Pico, Raspberry Pi Pico, you could buy just the chip, but I don't think people really buy just the broadband chip that's on the Raspberry Pi 4s, for example. So this is its own development thing. This is a separate tool I have that is actually a all-in-one unit for lots of different things. Obviously there's a breadboard on it, but there is a logic analyzer built in, a function generator built in, there's oscilloscopes built in. These two ports are for waveforms to go out if you have the BNC connector. These two are for oscilloscope connections if you have a BNC connector. There's some switches here to toggle on different power supplies that come out of these channels up here. So it's hard to see right now, but I have what do I have? I have 5 volts coming out of one channel and ground coming out of this other channel, and I can turn it on with this third switch. You see this? Oh, it's really hard to see on the camera. I should get a different camera setup. But anyways, this LED came on. There's a 5-volt power supply channel, so I can give power to my circuit and the breadboard really simply. There's some buttons, there's some switches as well. So it's kind of just like an all-in-one thing. And the best part of all that is that the actual tool to connect to it is through your computer, so you can serially talk to it and capture lots of different things. It's a pretty nifty tool. I really enjoy using it. It's helped me out with a couple different development things. I haven't gotten to use it super long, but I can already see its value. This one is called the STM, no, not STM. Let me go to the webpage real quick. This is the Analog Discovery Studio. It's this thing right here. It's, you don't have to get, okay, well, for one, it is pricey, but I kind of saved up for it. And if you don't get the BNC probes, it's the lower amount. If you get the BNC probes, it comes, it's a little bit more expensive, but I haven't needed to use them yet. But yeah, it's just kind of like, I was in a situation where I didn't really have a breadboard that I could trust. I couldn't really trust this thing, or sorry, trust the other breadboards I had. So I was like, okay, let me try and invest in a better one. And then I came across this. I was like, why not get a tool with the breadboard? And here I am. It also has a USB port on the side here, which, I mean, I'm using to power this camera, but theoretically you could use this port to power your board directly, so that way you don't have to have some crazy wires. Yeah, no, it's a pretty sick product. In fact, this is a huge plug for their business, so, you know, Digiland, if you want to help me out, I would be a good spokesman for this device, because I think it's a really solid device for learning and testing out stuff. Definitely more targeted towards students, and yeah, it comes with the scope. Yeah, buy once, cry once. Yeah, exactly. Like, it's been maybe 6 months since I bought it, so I kind of already forgot about the hurt it did to my wallet. So we're good. Oh, look. Okay, I guess you can just buy one just straight up. Hold on, if this picture would load, that'd be good. What is this? Okay, this looks like it plugs in. I haven't seen this before. So if you wanted to have a soldered breadboard, because like there's other stuff on this. What do we got here? Some ICs that I don't quite recognize. Maybe that's for soldering practice. Oh, these are different package sizes. Oh, okay. If you wanted to solder a circuit onto that and plug it into the same studio thing, you could. I do work in the embedded industry, yeah. At my embedded job, I kind of have my own tools over there, so this is more for like my own personal projects. If I ever did like consulting or side work, this is kind of what that would be for, or even just developing on stream. You know, it's just a handy tool to have, so that's kind of why I got it. Looks like this one might be one without the, oh, I see. So this is the canvas I have, quote unquote. I see. So you can have different modules. That's kind of cool. Cool little idea they have for making it more usable. Even comes with, you can even buy a case, funny enough. I don't know how often I would be transporting this thing. And to be fair, I feel like they should have just sold you this case when you bought it. Instead it just came in a box, but all right. I mean, shoot, maybe just 3D print your own box at that point. I don't know. Anyways, so yeah, I'll put the link to this actually in the chat if anyone's interested in looking it on their own. They seem to have a lot of different parts that you can buy too. How do I get back to that? Here we go. Yeah, here's the link to that. Okay. So, looked at the disassembly a little bit. Do they have any important notes they have? The output can differ on your system. New versions can generate different assembly. Okay. Yeah, I could see that. I mean, granted, there's just some extra stuff here, really. Like this is that crate that we call from. We get a new program canner address, I'm guessing, is going on there. Yeah, I mean, I don't really want to look through all this. I'll probably just skip past it. Just kind of looking. That's cool, though, that you can do that. Okay, what's next? So they're running it on QEMU. We're going to skip through that because we're going to actually just put it straight on the hardware. All right, so they compiled and so did we. The second step is to enter the memory region information into the memory.x file. Oh, okay. This is something we have to be active about. If for some reason, if you for some reason change the X file after you had made the first build, do a clean and then a build again. Okay, just like make. So, yeah. Do we have cat just normally? Cat-v? Doesn't look like it. Unless cat-version is a thing? No. I don't know. They use cat. Yeah, I know. Maybe I should get the tool you mentioned earlier. Maybe I should. Wait, is it actually super easy to get the cat tool? Do you think I just need to do cargo install like cat, or what do you call it, bat? Is that what I need to do? Because if so, I'll do it right now. I'll use Choco. Oh. Build from source? Oh, wow. Okay. Let me just see. Was there really no option else? Was it GitHub, Rust, Bat? Is that a thing? A cat clone with wing. They got a few different ones. You could use cargo. Okay. Oh, it looks like Mr. Bezos wants to run an ad break, unfortunately. Gosh darn it. Okay, well, 30-second ad break. I will look through this. Unless you're on YouTube. YouTube doesn't have ads. Just putting it out there. YouTube is ad-free. Okay, what am I looking for? Installation. Sorry for the ads, everybody. I try to minimize as much as they are. I literally have a slider going all the way down to the bottom of how long. I really wish I didn't have to have them in my stream, but unfortunately I accepted the affiliate and made the mistake. Okay, that's how to use it. Is it I feel like it, yeah, let me try cargo. Off we go. Off we go into the bat world. So if it works, I can just do bat and then file. Rip grep. There it is. I want to call it Rip Greg though. But grep would make it tied better. There's tail. They have no build for Windows. Interesting. Interesting. Wonder what this bat is installing then. I'm a little bit scared, not gonna lie. Installing awful lot. It's downloading it right now. If I search Windows. Okay, it is the thing. Never mind. This works out of the box. They did it through chocolate tea. Okay, so if I do bat 24.0. I wish they had a table of contents at the top. Yeah, that's a good point. They really should have. What is the version? 24? All right, it worked. Hard to see, but right here. Version 24. We're good. Cool. A new way to install tools. Alright, I don't even remember what we were doing before that. We want to use bat memory X. Sick. Even though I could just open the VS Code. I literally have VS Code right here. I just realized. Okay. Adjust these memory regions to match your memory layout. These values are corresponded for this. Okay. Luckily, I already did this in another project, so we will quickly grab the file I have from my C memory file. Use to close it. You should be able to use Vim commands to control. Oh, okay, to scroll. That's good to know. Okay. Alrighty. I think it is right here. PSP startup. I think I had it in my linker script. Let me open this on the code. Alright, here we go. So, if we were to compare the two. Actually, I think I can just do this. Yeah, there we go. If we were to compare the two, we just need to change that. Let's open it up in VS Code directly. Okay. So the RAM origin's the same. Dash color. Add color to the output too. Ooh. That's nice. Let's try that. Just for fun. Oh. Okay. Dash color. Oh wait, always. Oh, maybe not. Maybe there's no color to be associated with it. Memory files don't even have color in here, so yeah, I guess that makes sense. Okay. So we have SRAM here. I'll probably just do another region just like how we have it here. So we just need to change the length of our flash. And our flash is at a different region too. So we're going to replace this with an 8 and replace this with 2048. Okay. 7, 6, 8. And oh, well, I call it SRAM. I have a RAM. Could just keep it. I like to be similar though to my original C because I might compare and contrast the two. SRAM 4 origin equal to 28. And length is 16K. All right. It would be pretty cool to get color for those types of output. Yeah, I agree. It would be cool, but I guess that's just how it is. Is that higher than this ASM? This would be the layer where you're just describing your processor's memory. This would be a perfect time for the drawing screen to come out. But I feel like I could go on a really big tangent with this. So I'm going to try to keep it brief for now. Basically, this is just a script describing how your memory layout of your hardware should look like. When we opened that compiled code earlier, it was showing like the ISR is the first part of your code. Text was another part of your code. You have a data section of your code, or sorry, of your memory. These are all memory, by the way. A BSS section of your memory. And essentially, I'm just describing where to put this keyword in my physical memory. I'm like mapping it out. So ISR, I'm putting it in the flash region, which is defined to start at this memory address and go 2048 kilobytes. The text region, I'm saying that I want to put in the flash memory, and I'm aligning it because there's some nuance to the .load script, how they actually align it. I'm not a big expert on this, but the core of what matters is that you're describing where things are going. I kind of forgot what this keyword meant, to be honest, but I'm sure a quick Google search would describe what that would be. BSS going in SRAM. This is doing something with SRAM and Flash. Like, one's a dependency on the other, maybe? Can't quite recall. But anyways, so if we're looking at the Rust version, because the left one was what you use in C, the Rust version on the right looks like I need to be doing basically the same thing. Okay, so I don't really need to change much. I can maybe just copy it directly over. Yeah, I'm pretty sure I can. Okay, well, then we'll do that. So, using good old Vim, we'll just yank and paste. And then we should be good. That was really easy. Yeah, that was extremely easy. Links allowed. Could you elaborate what you mean by that? Let's see. Oh, like links are allowed in the chat? Is that what you're asking? Yeah, you can post a link. That's fine. Okay, see, example, putting non-initialized variables into custom RAM. That the section will be 0 initialized by runtime. Yeah, that's fine. Okay. So theoretically, we have memory. We got to rebuild though. This might help you with some of the core Rust language. Okay, is this the book you were reading? Oh, get out of that. Light theme, it's okay. It's okay. Let's see here. Oh, it's using, oh, there's only that light theme. No worries, no worries. What we can do is this. We'll make it so it can be readable on stream. So we'll zoom this in. So this is this the oh, is this a specific one? Your eyes flashbanged again. I'm sorry. Oh, hey, like we got structs. Is this documentation made by somebody? Oh, it's for CDev specifically. Okay, well, we'll go ahead and save that then. Once I get to writing the actual code, I think I might be looking through this. Yeah, definitely. Okay. Thanks for that resource. That's huge. Let's get through this part of it. We don't need QEMU. Okay. Let's get through this part because I think we're close to being done. I need to recompile it. So close this. Go back here. And I think they said cargo clean. Simple enough. Clean. And then cargo make. Oh, not make, build. It's time for sunglasses. Yeah. True, true, true. Oh my gosh. Ooh. Ooh, it didn't like that. Ah, I see. Because I changed it from RAM to SRAM, it didn't know how to link it, so we can easily fix that. Although we gotta see what file that was in. That file is in... Unless it just needs to be named RAM. Let's see, is there any comment about that? Let's see. Because if so, we can just add 16 to this and just treat them as the same. Actually, can we do that? I don't think we can do that because I think there's some protected memory right at the end of this. So we would just ignore SRAM 4 probably. Let's see. The stack is full of the sending type. You may want to use this variable to locate the call stack and static variables in different memory regions below is shown the default value. Okay, and what was our... Okay, that looks a lot like this statement right here. You can use this symbol to customize the location of that text. Do I need... Maybe I need this. Underscore stack. Oh, there's a book for almost every language to transfer to Rust. MSFT has a Microsoft FT. I don't know what FT would be, but Microsoft something. A Rust for C# devs, and Google has one too. Okay, that's good. They really are trying to get people to try Rust, so that makes sense that they would put the resources into that. It is totally worth it for them. Okay. It's interesting that it's... Oh, provide. This is definitely called somewhere else. So how about I go to that file? Link X. Okay, we have link X. What is this? Symbols that start with a double underscore are considered private. Symbols that start single are considered semi-public. Extern forces the linker to keep a symbol in the final binary. Short for Microsoft. Oh, it's their stock symbol. Okay. I learned something new today. That makes a lot of sense. Okay, so this actually has reset. Oh, hold on. This looks more like my... This be my make file? No, hold on. The fact that it has a reset vector here, this makes me think this is where the ISR stuff is called. Yeah, this is normally in my C file. Okay, interesting. So it really is looking for RAM. So I think to keep this simple, since this we're just trying to see if it compiles, we're just gonna get rid of the SRAM section of this and just call us back to RAM. So now we should be able to hopefully clean this. Cargo clean. Okay, wow. The spacing got all jacked up. Cargo clean. Cargo build. Ooh, okay. SRAM not declared. Interesting. Let's change it to just... Okay. Let's see. So we start with the hello example, but first we have to make a small change. we want to make sure debug exit calls come in commented out or removed. Oh, okay. We don't actually have anything. Our code doesn't do anything. That makes sense. I never coded it to do anything. Examples, hello? Maybe this is what they're talking about? Oh, because you can build... Alright. This is exactly how I had my C project set up, where I gave it a target to build by the name. So even though we did build before, either that probably just builds source, and I'm gonna need to learn how that build system is set up later. But I think if I go to examples and to hello RS and comment this out just like they said, do not run this on hardware, it will corrupt OCD state. When you build, it goes into target/debug. Like the actual file itself. Like it's built like the object obj. What I meant was my make file lets me, at least how I want to have it set up is I have a bunch of examples that I like to run, and I want to be able to choose which example to run when I eventually transition my library from from C to Rust. I want to set it up like this. Okay, so I commented it out. So we're gonna build this now. Cargo build examples. Is it with an S? No, just example, because not actually sure how it's just example, huh? Hello is what it's called. Okay, what we got here? Unused import debug. That makes sense because it's not used literally. But it compiled. Cool. So now we need to worry about OCD stuff, which I have installed already. This should work pretty much the same that I was using it with C actually. So we're gonna do two different windows here, not windows but terminals. We're actually going to close that too. So open OCD GDB is not what we want. I just want the function open OCD.exe. There we go. Oh, something's off. Okay. Is this running my local, or do I need another flag? Maybe I need another flag. Hold on, 10. This is 12. What's going on here? Let's widen this out a little bit so we can read this easier. To override transport select. Unexpected ID code. OB12. I shouldn't need any code on it to connect to the OCD. Select a target, took over low-level control. The result may differ compared to plain JTAG, SWC, or SWD. They don't get any error, I'd imagine, yeah. Let's see, if you found out that you have an older version of the discovery board, verify the section, you should modify open OCD file at the point. Unless it's pulling off of the source that it provided. Oh, maybe that was it. That could be it. That could definitely be it, actually. Get rid of these extra files. So they're saying they have OpenC ST-Link. Oh, yeah. This should be different. I didn't know it was actually pulling from this. Fact. How is it even getting that? Interface target. Oh, these are just generic names. Yeah, okay. It's listening now. Okay, yeah. I didn't know. I kind of forgot my command because when I used it in my C project, I had make STM flash, or maybe I just had OCD, or maybe I hard coded it. Either way, I had it set up differently. Okay. We need to use GDB to connect to the remote. So let's go ARM GDB. GDB, thank you. Okay. Or do I need to pass the file in? I think I need to pass the file in too. Yeah, I do. Okay, hold on. Quit that. We need... Oh, geez. Target. Is there only one? Oh, we have V8. Okay, sure. Debug, examples. Hello. Okay. All right, it's reading that symbol. Okay, we're in. Then we just do target remote :3333. And we should be connected to it. All right, we are good. We're connected in. Now load the code on. Theoretically, the code... Oh, what's this? Unable to match. That's fine. Halt due to debug request. Okay, I think that's fine. I think if I do exactly as it's saying here, I loaded the code on. Monitor ARM semi-hosting enable. What is this? The program is now loaded. Semi-hosting. So before we do any semi-hosting call, we have to tell open OCD to enable. Oh, isn't this the logging thing? I briefly read about this in the Rust docs. Yeah, I think this is new to me. Try monitor. Well, actually, if I do list main, this should show what code is loaded to it. Okay, so that is definitely our main code. Unless it's just pulling off of the source file that I gave it earlier, which it probably is. If I do break main before I turn on that, what happens? Oh, that's just putting a breakpoint, of course. Okay, we stopped at the entry, which is right where main is. So if I do step, which is S, we should be at the very next line. Okay, what would happen if I step again? Okay, that's what I figured. It has no idea where to print this thing. So of course we're gonna hit some kind of random interrupt. That makes perfect sense, and it thinks it's unsafe, which is fine. That's just an exception. So we're gonna go ahead and restart the code. Oh, what's restart on it? I thought R was redo. Crap. Remote target does not support run. I don't need run. I need... Crap. I need to look it up. Totally forgot. Oh, S? No, S is step. Oh, GDB restart program. Jump set. No, there's like one line word I can use. Sorry for the flashbang again. Reset. I was using it last time. What the heck? GDB rerun? No. Start program at beginning? Use the run command. Maybe it was run. I feel like it had to have been run. Target does not support run. Help target. Actually, let's not do that. Let's hit continue, see what happens. System call. Signal trap. Yeah, I mean, this makes sense. This is what I was expecting. Run. Load? Maybe load is what I need to do. Load? Yeah, load would just reload it. Okay, sure. Okay, that's fine. We're gonna go ahead and throw on the monitor and see what may change by doing this. So monitor, ARM, semi-hosting. Oops, what in the world? Then I hit enter. That's weird. I pressed tab. Monitor, ARM, and it just like auto-completed. Semi-hosting enable. Okay. Let's see what happens now if I do break main. Alright. Breakpoint at line 11. And continue. Alright, what did they want to do? So they continued. They stepped. So they stepped one line. They're at the hello print world or print hello world. Should see hello world printed into the OCD console among other stuff. Really? Is that what they think? I don't see that. Maybe I need to step one more. That's always possible. So step one more. Yeah, I don't see that. I don't know what should be happening. Message is only displayed once as the program is about to enter the infinite loop. You now exit GDB with the quit command. Huh. I guess we can just quit this and see if we can reload it. It would be too perfect if it worked first try, but that's alright. Okay, so we're in GDB. I'm gonna try that again. And maybe I needed a different version GB. I feel like I shouldn't. Because right here it's saying you could use just GDB. So yeah, maybe I'll just do that. Target. Usually I use extended remote as well. But let me try that this time as it's what I'm used to. Okay, sure, that's fine. We're gonna hit load to reload the code in. Monitor. I wonder if it's to do the remonitor thing. ARM semi-hosting. Oh gosh, see. Yeah, when you press tab, it does that weird entering thing. Not sure why. Semi-hosting enable. Then break main. Continue. Step. Okay, we halted one. If I'm not mistaken, we should have saw it. When they hit step. Advancing the program with next. Oh. Is that what I needed? Oh, shoot. Okay. There it is. Hello world. We officially did it. Rust is officially on the STM. Granted, I just followed the tutorial, but it's running Rust. There's no longer a need for C. See you later. See you later. Rust it is. We finally did it. So, I wonder what the difference between the step and next and the next keyword is. Or maybe it was the same and I just needed to properly do the instructions in order. What else do they got in here? Talking about debugging. They're saying there's a debugging script that gets created when I do cargo generate? Really? So you mean that whole thing I just did I don't need to do? Well, that's great. Oh well. So if I did my own GDB, do -x for executable, I pass in their script, give it the script file, or I mean the file name. Glad they added it at the end. Yeah, I know. Just so that way you can go through all that. Well, we got here at least. Oh, hold on, I need to plug in my mouse. Mouse just yelled at me for being low battery. Because I think that's what that beep noise was. Okay. Need some water. I mean, I could try that. I feel like it would just work though. I don't know if I really want to do it. This is connecting to the remote. Printing. Assembly demangled. Some setting called that. Putting breakpoints at default. Handler, hard fault. Rust begin unwind. What the heck is that? Maybe that's the, oh, that's what this is, right? No, wait, maybe not. And a call. I was thinking maybe that's what the unwind was, but maybe not. That's okay. Should I try it? Maybe I'll just try it. This shouldn't take too long. So if I do quit, all I gotta do is, where the heck did it go? Here, this one. Oh shoot, I was gonna stay on the screen. We will just copy this and then change it where we need. Or actually, I just gotta add one argument to it. Never mind. I don't need to change too much. -x. Oh my gosh, what happened? What in the world? Okay, let's try that again. The spacing got jacked up. Yeah, it's getting jacked up. Okay, well, we'll do it from scratch. Arm, none, GDB, -x, open, OCD, GDB, and then this long file path target. Oh wait, do we need? No, we're good. Target. Debug. That should just be example. Hello. Okay. So apparently we'll immediately get to a good spot. Not sure. Extern Z function reset. Does it talk about what it does when you run that? I guess not. So if I do step, or maybe lists, pre-initialization. Oh, okay. Yeah, never mind on that. We can do break main, and then it should just go straight to that. So if we do continue, and then step one more. Ooh, okay, step doesn't actually work. Next would work. That's good to know. We're gonna try to reload that and use next instead. I really need to figure out why that is. Outside of this stream, probably. Okay, break at main. And then step once. Oh, what the heck? Hold on. That doesn't look right. List? Step? I did a break. Oh, I need to press continue before I do that. Okay, yeah. Step once. Then next. Hello world. Okay, yeah. There's definitely a keyword difference there. Oh well. Noted. Do they have us doing anything else useful? Alternatively, you can turn this config script into a custom runner to make cargo run, build, and start a GDB session. Oh, this would be nice. Stream died. Oof. How about now? Is it still dead? Is it still dead? Let me figure that out. That's not fun. Oh, wait. Is it back? Is it back? I think we back. Okay. I get it looks like it just dropped for some reason. There's some drop frames maybe. Not really sure what happened there. That's not fun. Let's see. I can look at my stream stats and see what happened. Yeah, that's wacky. I mean, I do see my kilobits per second. It might have dropped a bit. Which that's unfortunate. Hold on, is it overview? How to navigate this menu to get. Stream settings, is that it? Nope. Channel. Okay, well, let's just hope it doesn't happen again. If it does, please let me know, because it's hard to find out on my own. Okay. What do we got here? So they were just saying they can use this config file to automate the previous step I just did even further. So that way I could run it. I think I will do that, actually. That sounds pretty awesome. That's exactly what I would want. Oh yeah, because we read this earlier. I just remembered. Right? Maybe this is talking about something else. Hold on. Wasn't there a GDB section here? Yeah, GDB runner. So if I... Ooh, but it's dropping a little bit. Yeah, as long as it doesn't go to like 700 kilobits per second, I think I'm fine. Normally I shoot for 10k kilobits. But when it you know went wacky or it dropped, it was at like 400. So I'm not really sure. I can look into that. Assuming it doesn't happen again, I can look into that off stream, hopefully. All right. So yeah, we got their example working, which is dope. It's his stream again. Okay, sweet. I'm glad it's stable again. Oh yeah, it looks like the numbers are doing good. Okay, sweet. Yeah, okay. This is good for the beginning of this. Now, what I really care about is this chapter right here, because this is really the core of all embedded development, is this accessing these memory map registers. I really need to get this working, and then I'm basically at the step I was last stream. So not much progress has been lost. It's just now it's in Rust, which is cool. So they're saying that I need to see if they have a crate that exists for my development board, which is on something called Crate.io. Huh. So if I search up STM32 U5, what do I find? Huh. Interesting. Interesting. That's what I use. Funny enough. I don't know if I trust it though, if I'm being honest. Because 000, version 000, I don't know about that. I don't know about that. That seems a little bit sussy. Interesting. It is interesting, but I don't know. Because this one, they straight up have a solid. This is a very. Let's try and look and see what this is about. So here they have a Rust thing for buttons. Looks like it's just an example of them blinking a button. So if they, or actually let's do Blinky. I should be looking at Blinky. Yeah, this is like the hello world of a bit. So maybe, or you know what? Maybe it was not talked about. Let's see. Here's that semi-hosting thing that they had me turn on the debugger or memory D. And when you're out of bounds, it results in a panic. Okay, so it's actively checking your current runtime memory location. Interesting. It unwinds the stack of the panicking thread unless the user opted for aborting the program of panics. Okay. Makes sense. You must have this function declared exactly once. Panic halt. Okay. And I guess that was good enough. Cool. Oh yeah, see right down here. Panic halt. A panic causes the program on the current thread to halt by entering an infinite loop. Ah. So you get to choose what it does when it panics. Okay. That's cool. That's cool control. Panicking messages logged to the host using semi-hosting. We panic. Yeah. I mean, if I have control, I mean, if I had with the drum machine, maybe I have the ability like to trigger it to do that or play some sound bite that I programmed to RAM. Some, I think, music last time. The music channel. The 4-bit PCM, I bet, is super crisp. Can't send message on the music channel. Oh, really? That's I must have done. I see. Okay. Hold on. I know how to fix this. Okay. I needed to give you a roll. I forgot. Go ahead and try. There we go. Heck yeah. Okay. We're gonna pause our music. I'm gonna listen to this on stream. Let's hear this. Oh, that's super blocky. What? Oh my gosh. That's like what you'd hear out of like a dying toy. Like a very old battery powered toy from like the 80s. Although this is like an extremely busy song for that kind of device. But you can actually tell there's some music. That's actually dope. I like that. I like that a lot. You made it print lol when you use a file exported in 4 bits. Let me see. Oh, I see. Nice. Oh, gee. Is this getting pushed to GitHub then with that option? Or are these just for fun? Own amusement. Yes? Okay. It's already pushed. Awesome. All of it. We love it. Oh, that's so great. Surely you can't get 2 bits to work. I'm just kidding. I don't imagine you can differentiate anything from a 2-bit one. 4-bit might be the bare minimum. Maybe 3, but probably just 4. You could do you could. I'm sure you could. I'm sure you could. I don't doubt that. It's just, I don't know if it would sound great. All the low bits. The low frequency, extreme bass. 2 bits is literally 4 values. Okay, what am I looking at? This, okay, they're just talking about how they used panic halt as a way to use the tag panic abort. Or, yeah. What else they got? Compiler would warn that, let's see, sometimes you might see extern create panic abort instead, which is an older style used since before 2018. Okay. We don't gotta worry about that. 1-bit true false, yeah. Okay, what are we? Oh, they're just talking about an example that would panic. Okay, this is just a regular program. That's cool. You can check the length though. That's just built in the language. That's such a handy function. This example chooses the panic semi-hosting behavior, which prints the panic message to the host console using semi-hosting. So when you do it, apparently it logs that you're out of bounds. The length is 3, but the index is 4. Nice. I like that. That's cool that I could do that. Exceptions and interrupts. Ooh. Are interrupt mechanisms, hardware mechanisms. You could just kind of reuse the logic you did on DPCM and just repurpose it to just immediately jump to one of the 2 specified. Oh my god. Oh no. I mean, yeah, I know you can. Oh, we hit the end of our playlist. That's surprising. That was a longer playlist. All right, what do we have? So, oh, ad break coming in 2 minutes. Oh, actually, I can snooze it. I have a snooze. I snoozed it. Re-implementing IBM speaker drivers playing 1-bit PC. Oh my gosh, yeah, of course. IBM speakers. Yeah, I mean, that's as peak as it can get, or wacky. I like that word a lot. That's as wacky as it can get. Exception attribute. Exception handlers look like plain functions, but there's one more difference. Exception handlers cannot be called by software. Oh. Following the previous example, the system tick statement would result in compilation error. This behavior is pretty much intended and is declared inside exception handlers are safe to use. So this would give you a compilation error? Or is it talking about something else? Cortex M RT create provides this attribute. So you have a function systick. You have a static commutable variable called count. That's a 32-bit unsigned value signed as 0. And the count has been transformed to pointer unsigned 32. It's safe to use. So this is a pointer, the reference pointer that you are setting axle from more than one exception / interrupt handler, or from main, and or one or more exception / interrupt handlers. So you should only ever call it once. Is that what I'm getting at? Safe Rust must never result in undefined behavior, so non-reentrant functions must be marked as unsafe. Yet, I just told that exception handlers can safely use static mute variables. How is this possible? This is possible because exception handlers cannot be called by software, thus reentry is not possible. I see. Okay, I hear random noise. I hear not a song. I hear a phrase that I will move on from. 1000 hertz sample rate. What's the difference? Hold on. You had a 48 on here. 3000. So that means it's going slow. Oh, wait. Sample rate's 3000. Goodness. That doesn't sound like a 1-bit. Okay. I don't really remember what I was going on. Here we go. So apparently this is how I can do. I need to figure out the syntax. I think, oh, I have two the same. Let me open up the actual Rust language document really quick. Oh, was Rust C the one that was sent earlier? Oh no, it's different. I think it's, hold on. Oh, it's this? No, that's create. I think it was under learn maybe? Oh yeah, I mean, oh, let's read the book. There we go. All right. Control flow ownership. That's a new idea. Structs, enums. This automated tests even? Oh wow. Wow. Oh, these are different examples, building stuff. You have functional language features? What the heck? This thing is supposed to do everything. Smart pointers. Smart pointers are data structures that act like a pointer but also have additional metadata and capabilities. This is a C++ thing. I never used them before, I think. Is there an example of a smart pointer? Values on the heap. These are smart pointers in the standard library. Okay, so that's a thing I can look into. Patterns and matching. Dang, this is a much stronger language than I was expecting. Dang, you even have an example where you build a multi-threaded web server. That's pretty sick. That's actually really sick. It's a unique feature and has deep implications for the rest of the language. It enables Rust to make memory safe guarantees without needing a garbage collector. I think this is where the pointers is most likely. Ownership, set of rules as govern how a program manages memory. Programs manage the way they use it. Some languages I'm just gonna skip through this. Program won't compile. None of the features of ownership will slow down your program while running. Because ownership is a new concept for many programmers. It doesn't take time to get used to. Oh, it does take time. The good news is that the more experience you become with Rust, yeah, okay. You understand? Okay, it's just telling me I need to understand it. And it's explaining this. Alright, the stack and the heap. Don't require to think about the stack and heap very often, but in systems programming languages like Rust, whether values on the stack or heap affects how the language behaves and why you have to make certain decisions. Structured in different ways, makes sense. Stack, you pop, okay, it's just regular. Heap is less organized. Memory allocator finds an empty spot in the heap that's big enough, marks it as being used, returns a pointer, which is the address. This process is called allocating on the heap and sometimes abbreviated as just allocating. Think of being seated on a restaurant. Yeah, okay, it's just talking about this. This is a queue. Pushing to the stack is faster than allocating to the heap because the allocator never has to search for a place to store new data. It's looking for an empty table. Accessing data in the heap is slower. Doing analogy, yep, that's fine. Just into the function, and the function's local variables get pushed on the stack. Okay, it's just like C. That's exactly like C. Keeping track of what parts of code are used when data are on the heap. Minimizing the amount of duplicate data on the heap, cleaning up unused data on the heap so you don't run out of space are all problems that ownership addresses. Alright, let's look at ownership. Each hope, the value will be dropped. Okay. Interesting. Variable scope. So, scope. So S is the owner of this value. And it's immutable because it's let. S refers to the string literal. Nothing really there, just them explaining the same things. There's two important points here. When S comes into scope, it is valid. It remains valid until it goes out of scope, so you can't use it. Data types. How does string relate to ownership? Yep. String literals where string is hard-coded into our program. They're convenient. First has a second string type. Big string. Oh, right, because you could just send the quotations without this function. This type manages data allocation on the heap, and as such is able to store an amount of text that is unknown to us at compile time. You can create a string from the string literal using the from function. Okay, the double colon operator allows us to use namespace particular from function under the string type rather than using some sort of name like string from. We'll discuss this syntax more later. Yep, okay. So from the string library, put this hello value in S. We can also make it mutable. So S is mutable. You're taking hello, putting it there. The YouTube is, oh no, really? Oof. Okay. Let me look. YouTube is messed up. Let me quickly check. Let's see. Green. Okay, what could it be? Green. I wonder if I could... I wonder if I could restart the stream just for YouTube. Green. Yes, yes. Green, green. Sorry about that. It's a dashboard? No. That's something else. Your power went out? What? Wait, really? Your power went out? If I go live, what happens if I click that button? I don't know why it's green. Wait, what if I changed scenes? Did that do anything? Oh, it did something. $30 minutes ago your power went out? Oh jeez. Is it just at your place or around town? Nothing happens on Twitch. That is true. Just wackiness sometimes. But I don't understand why. Ideally, okay, if I hit end stream, YouTube might end, but I could restart it. The area? Oh, okay. Maybe this will work. Hold on, what's this? Logged you out of Twitch and you don't remember your password? I don't know why it happened around you. I wonder if there's like they're working on something or somebody hit a power grid thing.